Hello friends, welcome back to You Can Do TV. Two centimeters off on the finished level, and a road built to last 20 years cracks in 3. A tiny gap between layers, and the whole surface splits open the first hard winter. Coming up, the entire chain of machines that turns raw rock into every highway, runway, and city street you have ever driven on. Do not skip the final segment. It will change how you look at every road under your tires. Every road on Earth starts with the same problem. You cannot pave anything until you have extracted the raw material to build with. And the way that extraction is happening is changing fast. In West Africa, surface miners now roll into open pits where dynamite crews used to work. The cutting drum grinds directly into the rock at controlled depth. Material comes out already sized for the next stage. No shock waves, no evacuation zones, no cracked foundations in nearby villages. Two methods run side by side. Side casting throws cut material to one side, protecting it from rain and letting operators sequence entire zones without interrupting other equipment. Direct loading feeds it straight into hauled trucks, lined up next to the machine. The same machine class is now being deployed to extract limestone and road-based materials, because if it works for bauxite in Guinea, it works for roadstone anywhere else. This looks like the most boring video ever, and it is pulling in billions. Wow. Now watch the same technology at a gypsum mine in northern Brazil, a 100-year-old blasting method quietly getting replaced by cutting. And this is where the extracted rock becomes actual road base. A 4-stage crushing plant running 350 tons per hour in Tamilmadu. Rock feeds through a jaw crusher first, then a cone crusher, then a vertical shaft impactor, then a screen. Output splits into 6, 12, 20mm aggregates and manufactured sand. Every grain has a spec sheet. And once you go bigger, the whole thing turns into a small factory that eats rock and spits out road base at 500 tons per hour. A bidirectional feeding bunker holds 55 cubic meters and decides whether material heads straight to the crushing line or into a stockpile. The cone crusher tears through the hard stuff, granite, basalt, andesite. The vertical shaft crusher turns medium hard rock into sand and gravel by spinning it against a lining at high speed. 3 vibrating washing screens separate output by grain size. 2 doddering screens pull moisture out of the sand. 1,000 tons of aggregate an hour, coming out cleaner than most kitchens. Why some highways stay smooth for 20 years and others crack in year 3? But a lot of it comes down to what happens at plants like this one. Where do you land? Is it the aggregate quality or the paving crew who takes the blame? Let us know what you think. Then comes the mobile version, a plant that packs up and follows the project. In a Sicilian quarry, a mobile impact crusher and mesh screen turns 700mm limestone blocks into 0 to 50mm road base at about 100 cubic meters per hour in one pass. The whole rig runs on a remote control the operator holds while standing 30 meters away. Now scale drops down again, but the pressure goes up, crushing in the middle of a city. Excavated rubble from Istanbul's financial district gets processed on site, saving hundreds of truckloads across town. A 55-kilometer road contract in Maharashtra needed aggregate faster than the old plant could keep up. A 350-ton-per-hour, 3-stage wheeled crusher took over and pushed output up 1.5 times. But here is the plot twist. The same crusher that eats fresh rock can also eat old road. Ripped up asphalt goes through a compact crusher and screen, and the output becomes recycled asphalt pavement for tomorrow's road. Same rock, second career. Finland does the same thing at a bigger scale. A track-mounted impactor turns torn-up asphalt into 0 to 16 millimeter recycled mix that goes directly back into new asphalt production. 0 landfill, 0 waste. $10,000 tons of recycled asphalt crushed in 2 weeks. A 2-stage mobile crusher train handles the volume at 200 tons per hour. Yeah, up to 70% of new asphalt can come from recycled material. And in the UK, a compact impact crusher takes 800 millimeter chunks of concrete and asphalt down to 20 millimeter output at just 11 liters of fuel per hour. Automatic gap adjustment reacts to changes in material without operator input. The output goes right back into new roads. But no matter how good the aggregate is, none of it matters until somebody carves out the ground it will sit on. The biggest job on any road project is not paving. It is making the ground beneath it ready. A large production bulldozer sits on the edge of a slope, pushing material downhill in slow, deliberate passes. Slow and steady is the plan, because trying to rush a 100-ton dozer on a slope ends in expensive paperwork. And this class of dozer is where the numbers get serious. 955 horsepower, a blade holding 42 cubic meters of dirt, and 8% higher productivity than the previous generation. Now watch what a dozer does when there is nothing there yet. No road, no cleared line, just trees and dirt. An older bulldozer pushes through wet, muddy terrain on a farm in Norway, carving a rough logging road through forest before winter arrives. The tracks dig in, mud flies, and behind the machine a path takes shape that trucks will use for years. This is not the glossy machine from the brochure. This is a decade-old workhorse doing the job it has done since it was new. The land will eventually be cultivated for agriculture, but first somebody has to make it reachable. Every road on Earth started this way. One machine, mud, and a plan. Then take it to a whole different level, building a road up the side of a mountain. In Papua New Guinea, a large bulldozer works its way down a near-vertical slope, pushing rocks and dirt out of the way as it goes. An excavator digs into the lower excavation, moving material into position for the road grade. Around them, forest, cliffs, and no easy way in or out. The photos look impossible. The engineers who signed off on the plan probably slept badly for a month. But the road ends up carrying trucks, and the villages upstream finally get a supply line. Then comes the specialized machine most people have never seen, a wheel tractor scraper. 4 of them work as a team, cutting clay over burden and moving it in convoy across a huge site. Trucks and excavators are the wrong tool here. A scraper loads itself, hauls at speed, and dumps in one continuous motion. And these are not simple machines. They are unique excavating and hauling systems in one body. Modern wheel tractor scrapers can load themselves, haul at speeds up to 35 miles per hour, and spread the material evenly without needing a dozer to smooth it out. On the right project, they beat truck and loader combinations on cost per ton by a wide margin. Configurations vary. Single engine open bowl for long hauls. Elevating scrappers for flat, work-alone jobs. Elevating scrapers for flat, work-alone jobs that double as finishing tools. twin-engine models for steep grades and heavy rolling resistance. Newer cabs run 21% bigger than the previous generation, with 76 decibel sound levels inside, quieter than most highway commutes. Sequence assist software collapses. 14 manual commands down to 4 button presses. Load, haul, dump, return. Payload estimator calculates tonnage by reading hydraulic cylinder pressures on the fly. The overall philosophy driving the whole design is simple. It is not how much you fit in the bowl. It is how often you fill it. Which machine surprises you more on a road project? The giant dozer everybody photographs, or the scraper doing the actual work 3 times faster? What is your take? Then comes the transformation from rough dirt into finished base. A grader rips the surface. A mixing rig injects cement slurry. A tiller blends it in. A pad foot roller compacts the whole layer. The paver lays asphalt on top. 1 road, 7 machines, 0 shortcuts. But even a perfect base means nothing if the grade is off by 2 centimeters. Man, that is a lot of controls for 1 machine. A modern motor grader gives the operator 2 joysticks, handling steering, articulation, blade lift, side shift, wheel lean, and blade angle, with GPS auto mode kicking in on both sides to hold the exact design slope. Get 1 wrong input and the whole grade goes sideways. Then the industry took the next step, building the grade control system straight into the machine. No external masts or cables, fewer wires, less downtime. The system corrects itself in real time. Now the newest generation gets ridiculous specifications. 233 horsepower, a 14-foot mold board, integrated 2D or 3D grade control, floor-to-ceiling cab windows, and extended service intervals. Precision that took a 5-person survey crew in the 1990s now happens in 1 pass by, 1 operator, before lunch. And when the project is big enough, the graders scale up to match. 4 models pair with the trucks they support. The smaller size matches 40 to 80 ton haul trucks. The next handles 80 to 120 tons. Above that, the biggest units keep pace with 180-ton haulers moving through open pit mines. The largest grader weighs over 60 tons on its own, a finishing tool heavier than the road base it grades. For anyone who has actually operated a grader, how many hours before the joystick feels like an extension of your hand? And the last piece nobody films. The gravel spreader attachment, a hydraulic tow-behind unit with reversible cutters follows the grader, spreading gravel to exact thickness in 1 pass. Simple, and the reason maintenance crews finish before dark. The part drivers never see is the part that decides whether the road holds up for 20 years or falls apart in 3. At an industrial site in Texas, cement soil stabilization runs quietly next to a working roofing plant. A grader breaks up the surface. A water truck applies liquid. A stabilizer mixes cement into the soil. Rollers compact it. Dust-free process, so the plant next door keeps running, and the workers stay occupational safety and health administration regulations, which is how you know somebody actually thought about the neighbors. Then comes the mysterious white powder every driver has seen at some point. Lime kiln dust. Applied to over-wet clay, mixed 12 inches deep. Compacted with a sheep's foot roller, 72 hours later, ready for stone. That is the whole trick. And when the ground is really bad, you have to reach further down. A drilling rig injects grout into weak soil and mixes it in place, creating soilcrete, columns that carry the load of a bridge above, underground concrete pillars nobody sees. Now watch what happens when hydrated lime slurry hits tilled soil. The ground starts steaming like a chemistry set went off. The reaction is real. Calcium ions bind with clay particles. Water content drops, and the soil goes from swampy mush to a stable base in a matter of hours. A grader keeps working the mix. A roller comes behind and locks it in. Workers in vests stand back and watch the steam rise. Skip the step or rush it, and no amount of expensive asphalt on top will save the finished road. The first crack shows up in about 18 months. Everything after that gets uglier fast. Then comes the specialized machine that does mixing at a level ordinary equipment cannot touch, a soil stabilizer with a variable mixing chamber. Deployed in Uttar Pradesh, this reclaimer handles both milling and mixing in one pass. Depth is adjustable. Binder distribution is uniform. The mixing chamber can be tuned in real time based on soil conditions. The result is a homogeneous stabilized layer with consistent properties from one end of the tuning to the other. The crew on this project probably spent more time waiting for the water trucks than for the machine itself. And that same machine also builds cement-treated subbase straight on the road. Reclaimed material stays on site. Binder mixes in. Compaction follows. 0 trucks running material back to a processing plant. Now flip the whole idea around. Instead of building new, tear up the old road and reuse it. A cold recycler mills the existing asphalt down to the base layer, processes it in place, and leaves it ready for a fresh top course. The old road becomes the new road minus the truck fleet. And when you go bigger, the numbers get seriously appealing. A 3.2-meter milling drum recycles the whole road width in one pass. 1 water truck, 1 bitumen truck, 1 milling machine. Traffic reopens fast. Carbon dioxide emissions drop steeply compared to hauling everything to and from an asphalt plant. Indiana runs the same concept with a full paving train. Cement gets spread on the existing surface at a prescribed rate. An emulsion tanker follows, pushed by a water truck, pushed by the recycler itself. All connected by push bars. 2 truck drivers steer for the whole convoy. That is it. The recycler cuts 4 inches deep at 25 feet per minute, feeds directly into a paver hopper, and a roller closes behind. Live traffic drives past the entire time. And the ultimate test of all this is a military airfield rebuild. Pope Army Airfield, home of the airborne, in service 70 years. Cement soil stabilization plus a roller-compacted concrete drainage layer beneath the new runway. The Army Corps of Engineers signed off. That runway holds up for another few decades. But even the strongest stabilized base means nothing until every layer above it is compacted to spec. And that is where the real numbers start. Density is where a road lives or dies. A tamping-foot soil compactor rolls through muddy, rocky terrain, pressing every square meter of the fill layer to a target density. Get 92% instead of 95%, and the road settles unevenly. 2 years later. Then comes the machine that turns compaction into something closer to a controlled earthquake. A high-energy impact compactor delivering 22 kilojoules per drop. The segmented rolling mass strikes the ground repeatedly at the right frequency, driving compaction 2 meters deep, way more penetration than ordinary vibratory rollers reach. And this becomes essential when you have to build on soft ground, like a former mining site. A polygonal drum roller compacts 45,000 square meters of colliery waste into a stable platform ready for residential construction. Real-time compaction data uploads live to a map. Every pass tracked, every zone verified. Then comes the pneumatic tide roller, the finishing touch that seals the bitumen coat. 24 tons of ballasted weight rolls over the final surface, closing pinholes that would otherwise let water in and destroy the road from below. And the ultimate expression of all this is a racetrack, where a bump measured in millimeters becomes a crash at 180 miles per hour. A 28-person crew flew across the country for a 41-day project window, cut short by summer thunderstorms. Multiple rollers worked breakdown, intermediate, and finished positions in sequence. Owner expectations exceeded. Every millimeter accounted for. But which stage do you think matters most for how long a road lasts? Subgrade prep, compaction, or the paving itself? Where do you land on that one? And once the layers below are locked in, the paving train comes to life, and it is way more complicated than one machine laying asphalt. Paving is not one machine. It is a chain of them, each depending on the one in front. A chip spreader lays crushed stone at controlled thickness, while a paver behind seals it in. One misstep in the chain and the whole run stops. Now watch what changes when the aggregate spreader stops going backwards, a forward-moving version that drives itself. Traditionally, aggregate spreaders reverse toward the sprayed binder, which means a spotter has to stand behind guiding the driver. Backing into power lines, trees, and bridges was a real hazard. The forward-moving design eliminates the reversing part entirely. The truck loads its own hopper from a loader, drives forward, and spreads aggregate onto the road ahead. No spotter, single operator. A compactor roller closes behind. Oh, a job that used to take 3 people and a lot of nervous glances at overhead wires now runs on one operator, from one seat. Then comes the attachment nobody puts in the highlight reel. The base spreader, bolted directly to a bulldozer or wheel loader blade. The 7,125-pound spreader lays base material at widths from 10 to 16 feet and depths from 2 to 22 inches. Setup takes 20 minutes on site. The Army Corps of Engineers specifies it for airport runways because it prevents material separation, the primary reason many road bases fail early. And when the job runs across bigger stretches, the spreader has to tow its own supply. This chip spreader hauls loaded supply trucks into its 4 cubic meter rear hopper while it moves. A 6-cylinder engine and hydraulic 4-wheel drive keep the whole rig moving under load, even on marginal road conditions. Aggregate flows out onto the freshly sprayed emulsion at controlled rate and width. Surface dressing that used to require a full traffic closure now happens with a single moving convoy, while the road itself is still partially open. Then comes the mobile feeder, the machine that keeps the paver from ever stopping. Trucks dump into the feeder. The feeder dumps into the paver, no cold joints, no truck bumps in the finished mat. Now watch what a real paving train looks like at industrial scale. The Port of Hamburg container terminal, 30,000 square meters of new asphalt. A track paver with a fixed-width screed handles the laying. An offset power feeder runs alongside, taking the load from delivery trucks and feeding the paver continuously. Base course goes down at 13 centimeters. Base course goes down at 13 centimeters in strips 8 to 10.5 meters wide. Average paving rate. Whoa! 450 tons per hour. Non-stop. Additional container storage areas at one of the busiest ports in Europe, and none of it happens if the paving train drops out of sync for even a few minutes. And the final evolution, a full-line paving train laying continuously reinforced concrete instead of asphalt. In Conroe, Texas, a placer spreader led the first ever full-line concrete paving train over pre-laid rebar. Cement trucks dumped into the spreader distributed concrete across rebar mats. A slipform paver behind laid finished pavement 26 feet wide with continuous reinforcement built in. The project ran 3.8 kilometers long, completed 1 week ahead of schedule, 40% higher productivity than a conventional setup. Reinforced concrete pavement is famous for low maintenance and durability, which is why more state highways are moving toward it. And this is the piece drivers actually notice, the finished top layer showing up. On a 6.8 kilometer stretch of German highway, The largest road paver on Earth goes to work. Maximum laydown rate, 1,800 tons per hour. Maximum paving width, 18 meters. 2 mobile feeders keep it supplied, while trucks rotate on staggered arrivals. Base and binder courses get paved without joints across 12 meters wide. Up to 4,000 tons of asphalt per day, virtually non-stop. Now scale the whole thing up to a section carrying 84,500 vehicles per day. 3 lanes plus the hard shoulder get paved without joints, widths ranging from 14 to 16 meters. Screed extensions adjust hydraulically at 125 centimeters per side, giving a total 2.5 meter adjustment range on the fly. The rear chassis height rises at the touch of a button, so material transfers from the feeder always come in from above. That guarantees maximum feed even when laying extremely thick layers, with uniform mix in front of the screed across the entire width. 3 bridges along the route mean the paver has to reposition and remember every setting. Automatic recall handles all of it. Then comes the trick American highway crews swear by: 4 pavers running side by side in echelon formation. Cold joints are weak spots where 2 paving passes meet after the first has cooled. 4 pavers laying fresh asphalt at the same time. Hot edges bond seamlessly, no weakness in the mat. Nothing to crack open in year 3. And to keep that paving continuous, one specialized machine sits between the delivery trucks and the paver, the material transfer vehicle. Trucks dump asphalt into the transfer vehicle. Trucks dump asphalt into the transfer vehicle instead of directly into the paver. The transfer vehicle remixes the material, evens out the temperature, and feeds the paver at a constant rate. The paver never stops, the mat never cools. Rollers close behind immediately. Skip the transfer vehicle and every truck arriving late becomes a cold spot in the finished surface. 6 months later, that spot cracks. 2 years later, it needs patching. Nobody wants that job. Interstate 64 in Kentucky runs the same setup live. The shuttle buggy transfer vehicle shuttles between the hot mixed trucks and the paver, keeping the paver moving without a break. The result is a smoother pavement drivers will not notice for a decade, which is exactly the point. Then comes airport work, where the entire runway has to close for a maximum of 10 days. 2 inline paving trains lay 17,700 tons of asphalt over 3 days. Hot on hot, then hot next to hot, at 15 meters wide. Now switch materials entirely from asphalt to concrete slipform paving. A 3.7-kilometer runway at Western Sydney International Airport uses true slipform paving and Australian aviation first. Higher efficiency, less material, better safety. A slipform concrete paver is a completely different animal from an asphalt paver. It paves widths up to 24 feet with a telescoping frame that expands to 16.5 feet without inserts. 10 vibrators are standard, running through 18 variable control circuits, driven into the concrete at exact spacing. The augers split into left and right side independent control, spreading concrete evenly and keeping consistent head in front of the mold. Pressure-compensated side plates come off headers cleanly. A trailing adjustable stainless steel section provides the final finish to the concrete slab. The tractive system runs a slow, smooth crawl. Anything faster, and the concrete tears itself apart before it sets. Then bring that machine to Detroit Metropolitan Airport, where the stakes are actual airplanes. The slipform paver receives concrete straight from dump trucks feeding its hopper. Crawler tracks move at slipform crawl speed. Workers on the platform monitor every parameter and adjust as material moves through the mold. The concrete extrudes into a smooth, uniform surface behind the machine. A worker with a screed finishes the edges by hand. Every square meter has to pass inspection before rubber ever touches it. Airplane tires are less forgiving than car tires by a wide margin. But laying the concrete is only half the runway job. The surface has to be textured for grip and cured with the right compound. A 4-track texture cure machine handles both in one pass. 4 tracks turn 90 degrees so the machine loads and moves site to site. Frame sections add or remove for different runway widths using a walking and car design. Get me right. 1 pass instead of 2. Less fuel. Less time. Airport stays closed a shorter window. Every hour saved is thousands of dollars back to the operator. And here is what the industry moved toward. Rapid hardening concrete cured 1 hour after placement. Holy cow, a 40-centimeter thick concrete pavement handling heavy tug loads 2 hours after laying. Airport repairs without shutting down operations. Meanwhile, at one of the busiest airports on the East Coast, the same idea runs at night. A slipform paver lays fresh concrete under floodlights while an American Airlines jet taxis past in the background. Workers finish the edges by hand. The paver crew has until dawn after that. Planes arrive on the exact surface being poured tonight, but no matter how perfectly the new surface is laid, one thing is guaranteed. Someday the whole thing has to come out and start over. Rome's Olympic Stadium athletic track needed a rebuild, and the trick was bringing a cold milling machine into a stadium bowl. Precise leveling, first-class performance, every millimeter tracked. Then comes the newest generation, and the specs jump hard. A new 18-liter diesel engine puts out 627 kilowatts, 841 horsepower, with engine power up 19% over the previous generation and fuel consumption down at the same time. The Milling Assist software runs the whole operation, tracking carbon emissions per cubic meter of material removed. Now the flagship, two 18-liter engines delivering 900 kilowatts combined. Depending on the job, the software runs one engine or both. Partial load operation cuts fuel consumption while keeping high output. Milling widths from 2.2 to 3.8 meters. The multiple cutting system swaps drums quickly, so one machine handles surface milling and full depth removal on the same shift. And the whole point of these machines is not power. It is precision. Perfect milling surfaces are the foundation for whatever comes next. Milling in Shanghai, milling in Beijing, milling at 2 a.m., milling at Beijing, milling at 2 a.m. in the middle of Berlin. Different cities, same requirement. Then comes the compact version, because not every road is a highway. Milling widths from 0.6 to 1.8 meters. Big conveyor slewing angle. Ideal for city streets where a full-size machine would not fit past the parked cars. And when the road is a bicycle path less than 7 feet wide, only the smallest machine gets the job. The compact miller removes the full asphalt layer, saves fuel, and loads a dump truck via conveyor, all in one pass. But cold milling is only the start of a longer cycle nobody talks about, because a road that gets rebuilt keeps getting rebuilt forever. Reagan National Airport, primary runway 119. One of the busiest in the country. Year 1, 8 inches of existing material removed and replaced every night. 800 tons on average per shift. 15 feet wide, 1,000 feet long. Year 2, a new 2.5-inch surface layer across the full runway width. Every night, 300 feet by 100 feet. Gets milled and paved, pavement markings reapplied. Ready for service at 6 a.m. sharp. 3 milling machines, 1 paver, 3 roller sizes running compaction and joint work. Runway has to reopen every morning. 0 exceptions. The FAA specifies exact numbers for compaction, elevation, and smoothness. Hitting all 3 at once, in the dark, an 8-hour window, is why specialists get flown in. What happens if the paving team misses their reopen deadline at an airport this busy? Roughly 40 flights sit on tarmacs elsewhere, Where do you think the real pressure comes from? The FAA spec or the airline lawyers? And on Highway 37 in California, a 7.5-mile stretch of milling covers 181,000 square yards. 3 machines run together. Micromilling with 6mm drums, standard practice for smoothness now. Every road on Earth is a cycle nobody finishes. A new surface today is a milling job in 8 years, a base rebuild in 20, and a full reconstruction someday after that. The materials keep moving through the loop. Meanwhile, the industry is quietly rethinking the whole thing. Recycled asphalt now goes into new highways at up to 70% content. Rapid hardening concrete is closing airport repair windows from days to hours. Autonomous grading is landing on job sites where operators used to stack years of muscle memory. The biggest change coming in road construction over the next 20 years is not the machines, it is what percentage of the road ends up being recycled from what was there before. Share your thoughts below. If any of this shifted how you look at the road under your tires, hit subscribe. Next time, a different industrial world is coming into focus. See you. Take care.